Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve another gate question. This question was asked in the year 2001 for 1 marks, and it is related to the topic of process management. To be more specific, it is related to the concept of interrupts. So let's read this question. So the question goes something like this. A CPU has two modes. One is privileged and the other is non-privileged, right? Now the question asks that in order to change the mode from privileged to non-privileged, basically here we are lowering or dropping the privilege, right? So the options are a hardware interrupt is needed, B, a software interrupt is needed, C, a privileged instruction which does not generate an interrupt is needed, and finally the last option is a non-privileged instruction which does not generate an interrupt is needed. So now let's see how to approach this question. So basically, if you see, we want to change from a privileged to a non-privileged mode, and this happens when generally when we are returning from the kernel to the user process, right? When we go from the user process to the kernel, then we raise the privilege level, that is from non-privileged to privileged. But when we do the return, that is when we are returning from the kernel to the user process, that is when we change the mode from privilege to non-privilege, that is drop the privilege. So here we are talking about returning from the kernel, right? The first thing that you should observe is that the first two options, a hardware interrupt is needed and a software interrupt is needed. Actually, both a hardware interrupt and a software interrupt do the other way around, right? Whenever there is an interrupt, if you recall the definition of an interrupt, when there is an interrupt is basically a signal which can come either from the hardware or it can come either from the software. This signal is used to notify the CPU that there is an event that needs immediate attention from the operating system, right? And when the CPU detects this interrupt, it immediately halts the current user process. It immediately stops whatever it was doing and transitions the control of the CPU to the operating system. So whenever there is an interrupt, right, the transition from the user process to the kernel takes place. So obviously the privilege level will be raised. So whenever there is an interrupt, whether it is a hardware interrupt or it is a software interrupt, the privilege will go from non-privileged to privilege level. But here we are talking of the other way around, right? That is, we are talking about lowering the privilege. Just to give you an example, let's talk about system calls. So this is the detailed flow of system calls. We have talked about this in a previous video. So here I just want you to focus on the two transitions. Here you can see this red glowing arrow is where the transition from user process to the kernel is taking place, right? This is a system call, this is a software interrupt. And when the user process invokes the system call, there is a software interrupt, and the CPU immediately forces the transfer of control to the operating system. And here, in response to the interrupt, when the transition is taking place, the privilege level is raised from the user mode to the kernel mode. Whereas when we return from this system call, when we return from this software interrupt, the privilege level is dropped, that is switched from kernel mode to user mode. So the two options that we have, that is the hardware interrupt is needed and a software interrupt is needed, is wrong. Why? Because if there is a hardware interrupt or if there is a software interrupt, whatever is the case, in case of interrupts, when we have an interrupt, the privilege level is raised, not dropped, right? But in this question, we are talking about dropping the privilege. So you can see, in order to change the mode from privilege to non-privilege, we do not want to raise the privilege, we want to do the other way around, we want to drop the privilege. So an interrupt won't help because an interrupt would only raise the privilege. So option A and option B are definitely wrong. So now let us look at the remaining two options, that is option C and option D. So option C is saying that in order to change the mode from privileged to non-privileged, we need a privileged instruction which does not generate an interrupt. Whereas in option D, it's saying we need a non-privileged instruction which does not generate an interrupt. So first of all, one thing is clear is that whatever instruction that we need to drop the privilege, it should not generate an interrupt, because as we discussed in the first and second options, right, in case of an interrupt, whenever there is an interrupt, the privilege is elevated. We do not want to raise or elevate the privilege, we want to lower it. So any instruction, whether privileged or non-privileged, it should be first of all an instruction which does not further generate an interrupt, right? So having this cleared out, now the question now boils down to whether we need a privileged instruction or do we need a non-privileged instruction. So let us first of all come back to this diagram, right? So this blue region is the region where we are in user mode, the lower privilege, and this red region is the one where we are in kernel mode, the higher privilege. So first of all, let us understand why do we need the privilege in the first place. We need the privilege. It's because it's a kind of authorization to do sensitive things. The kernel has the privilege to do sensitive things. It has the privilege to access all the memory locations, the IO device registers. It has the privilege to execute all the instructions that the machine has to offer, right? So we can say that the kernel has complete control over the system. It is authorized to do anything. Now, as we have heard, with great power comes great responsibility, right? So if the kernel has all of the privileges, then it must be doing things in a proper way. So that is not an issue because the kernel is the only piece of code that we trust. It's a trusted piece of software, right? So the kernel has the privilege and it can do sensitive things. That is fine. And on the same grounds, the user process does not have the privilege. Like that is why it makes system calls, because it is not allowed to do a whole lot of things. It cannot access all the memory locations. It cannot directly interface with the hardware. It cannot execute all the instructions. That is why the user process, because it does not have the privilege, makes the system call. Because when you are in user executing user process, they cannot be trusted. So the point is that we need the privilege if we like basically whatever we are about to do, if that is something, a sensitive operation that has a consequence, then we need a privilege. But here we are talking about lowering the privilege. Here we are talking about dropping the mode from privileged mode to the kernel mode to non privileged mode, that is user mode. Here when we lose the privilege, when we are finally in the user mode, right, then the final result is that whatever we do in the user mode, it is not harmful, it is not sensitive, right? Because we do not have the privilege here. So the point is that you do not need a privilege if whatever you are about to do is not harmful or not sensitive, right? So dropping the privilege does not require a privileged instruction. Although if it is a privileged instruction, it does not cause any harm, right? It is like being over precautious, but it does not if we talk strictly, then dropping the privilege does not requires a privileged instruction. So let me summarize what I wanted to say. So basically we need to be in privileged mode only if whatever we are about to do has some major consequence, or if we do not do it properly, it can go wrong, right? That is when we need the privilege. That is why the operating system runs in privileged mode, because it has access to the complete hardware. But if you're running in the user mode, right, then you anyway cannot make much harm to the computer system, because everything is out of your reach. You cannot access the sensitive memory locations. You cannot access any you cannot execute all the instructions. So in the user mode, you are kind of powerless, you are kind of non-privileged, so you cannot do anything consequential or something which can do harm. So basically if you're in kernel mode and if you want to go to user mode, then you're going from a state where you can do more harm and trouble to a state where you're kind of powerless and harmless. So you do not require privilege, right? So the option C, that is a privileged instruction is required, is wrong. We can have a privileged instructions, but it is not essential to have one. We need a non-privileged instruction, it will be sufficient, right? And one final thing that I want to talk about is that when going from user mode to kernel mode, that instruction is a non-privileged instruction. You might ask, is that we are going from user mode to kernel mode. In kernel mode, we will be doing things which are consequential, which can cause harm. So why the instruction that transitions from user mode to kernel mode or elevates the privilege is a non privileged instruction? The reason is that if you're running in user mode and you want to go to kernel mode, you cannot be already in kernel mode, right? So that instruction, if every user process has to be able to execute it, first of all, it has to be a non-privileged instruction, because you do not have the privilege. How can you execute a privileged instruction, right? In the user mode, you do not have any privileges. You want to go to the privileged mode, but so the basic idea is that you cannot have a privileged instruction to make that switch. It has to be a non-privileged instruction. But there is a catch, there is a safety mechanism here. The safety mechanism here is that non-privileged instruction generates an interrupt, right? Whenever you make a system call, or whenever there is an exception, or there is a hardware, basically whenever the user process which is executing in the user mode, it wants to go to the kernel mode. Basically, we are talking about system calls. Whenever the user process requests some services from the kernel, that trap instruction, you can see this trap instruction, it generates an interrupt, and from there on the user process loses all control, and the control is with the kernel, right? So this interrupt is a safety mechanism, because after the interrupt has happened, it is the kernel which takes care of doing things in a proper way. So going from user mode to kernel mode, that instruction cannot be a privileged instruction, because we cannot execute privileged instructions while being in the user mode, right? It has to be a non-privileged instruction. And the safety mechanism here is that this trap instruction generates an interrupt. It's not a normal instruction. It is a special instruction that generates an interrupt, which brings the operating system into the picture to take things from here, right? And to summarize, when returning from privileged to non-privileged, we are going from a state where we can do harm to a state where we are harmless. So we do not need the privilege while we are going to the user mode, right? So this was the idea, that why we do not need a privileged instruction, although it does not harm to have a privileged instruction to lower the privilege. So the correct answer is option D, that is, we need a non-privileged instruction to lower the privilege. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.